Good morning. This is Cody Henriksen, and today we're going to be looking at an introduction to advanced data structures. This is for the CS 1410 Java course, but also apply to some of you who are working in your AP Computer Science courses as well. Now, I want to take a look at the fact that there's more to data and storing information than simply the basic ones we're working with of array and array list. And yes, I'm talking to your too. We'll take over there. Now, although most basic data structures can tell everything with a simple linear structure, whether it's a fixed size or dynamic size, that doesn't meet the needs of everything we're actually doing, especially when we're talking about real-world information. When we're trying to model the way that the actual world works, or trying to solve complex problems, simply a one-dimensional fixed or growing size structure just doesn't cut it. So we have to look at doing some more things with that beyond simply using array and array list. Now, if you take everything down to itty-bitty bits, you can probably make a one-dimensional structure work to cover most of your needs. However, the work you're taking to take the big project down and squish it and fit a tiny little square hole is really actually going to make a lot of waste for you to do that. So you don't want to actually use array and ArrayList for everything. You want to use the right tool for the right job. Additionally, when you continue on in computer science, especially the next class after 1410, you're talking about the data structures and algorithms course, you're really going to go in a deep dive and find out what makes it tick behind the scenes. How does all this stuff that work, including array and array list, what's the structure in memory and structure behind that and how the connections are made between the things we're storing? How do we work with that? And so by giving a quick introduction here, this will be a great source to take a look at that in the future and to see how the different ways of handling data structures are and what to do with that. So we'll go ahead and take a look at this. Now, we're working with Java specifically. Java is the language we're working with in our 1410 course. There were other languages out there. I know there are things besides Java. C++ is one of them. And one of the problems we see when we're working with programming languages is there's sometimes some late adoption to try and solve some big problems. One of the bigger problems we saw was the fact that there was a lot of replication of work, especially in C++, until the addition of the standard template library, sometime between 1994 and 1998, depending on when you're actually looking at the structure of that. And C++ had been around for over 20 years at that point. Oh my gosh, that's crazy. So they have all this stuff that's working and everyone's reproducing all the work over and over again. I remember when I was in school and learning computer science that there were multiple different styles of things you could use. I remember talking with people, there's the idea of the vector that's part of C++, but there's also AP vector. It's like a little tiny version of vector. Now there's some ideas you can actually, it's like we have a little simple version of it, that's okay. But it wasn't just the fact there's an AP version, there's also the textbook B, textbook C, and textbook D version of how to handle all this stuff. And by replicating and overusing all that stuff, it really made it so it was wasting time and structure and learning because students would learn, and beginning computer scientists would learn only one little version of the thing, and they're like, wait, there's this other thing that works the same, has different method names and structure. No. Good naming conventions, good style, good approach to this. And so Java really took a great structure with this, and they said, hey, we're going to have the Java Collections API, or the Java Collections framework, built into Java starting in 1.2. Boom, we've got this, let's use it. And with that Collections framework built into the Java existing with the Java Collections framework built right into language, it really made it so it's easy to have a set of structures we can use and expand upon because they're all extensible. We can extend from them, we can inherit from them, and we can build our own custom structures. If the built-in structure isn't good enough, we can make it even better because, hey, we've got our custom project and we can do this. And so we have that built-in framework starting along with the Java Collections API, starting in Java 1.2. We're now in Java 14. Yeah, so this has been in there for quite a while. And so we've got some good stuff, and we'll take a look at that as we go through. And this, again, is just an introduction. We'll talk more about this as we continue on with computer science, and definitely take some more research on your own to take a look at this and see what you can do with it. Now, there's a couple different data structure styles. We have linear data structures, and then we have the non-linear. Just step over here to the side for a second. Yeah, I know. So we have the ones we've been working with all along. So we have the linear data structures of array and ArrayList that you know and you're comfortable with. And then there's also 2D arrays. And a 2D array, well, it's really just an array of arrays. So guess what? It's just a collection of linear data structures. So it's nonlinear, but yeah, we'll talk about that some more. On the linear data structure side, we have these linear data structures I want to make sure I explicitly talk and bring about because we want to make sure we have an introduction to it. These are the main ones you have to know, and you should definitely take a look at this. So the first one we have on the list is vector. Now, vector is basically just ArrayList, but thread safe. Yes, you can now have it so it can work with things in a multi-threaded environment, such as a GUI, such as a application where you're spawning off threads of applications and want to collect data at different points in time. And this is something you definitely want to work with when you're trying to make sure you have multiple ways you can interact with data, but you're not sure when that data collection is going to happen. And so a thread safe structure is really important. So that's when you want to switch to using a vector for that. And it works almost exactly the same as an ArrayList. Great tool, wonderful, and it works, and it's a nice thing. And vector has that great name. I know. Yeah. Now, it's not quite the same vector from physics land, but it is what it is. Okay, moving on over. We have our linked list. The linked list is also like ArrayList, but with an enhanced backend. Now, we'll talk more about this as we go into a little more detail here in just a minute, but it has the same basic structure of holding things, and it can grow and resize as needed, but it has a backend that really makes it so it's great for doing manipulation. We'll talk about how. The next two data structures are the stack and the queue. The stack and the queue are a philo or a FIFO structure, depending on which one we're looking at, and these are ones that they are linear, but they work a little bit different, and we'll take a look and see how we can make that happen here in just a second. Like I said earlier, the linked list is really like an array list, but with an enhanced backend. Specifically, instead of having a dynamically resizing array that at least doubles in size every time you have to get to the point where it's getting full, a linked list has what's called a double linked list as backend. And so what it has as the backend is it has like little cells that hold the values we're working with, and those cells connect to each other. And so we can have one that connects to this one connects to this one, and it has like two connections, one on each side, and so we can have it so we can make a circular connection, we can connect back and forth to this. You can do all sorts of cool stuff with that. And so because we have those connections happening, instead of having an array of just these things that are pre-built in and just doubles in size every time it gets too big, we have like this with making these connections like this. If I need to move something, I don't have to actually move this right here. I can just move this connection right here, go down and grab this thing right here, and I can have it so that this goes to this. That points to me, and I don't have enough fingers to make this work to actually show what's going on, but I have this new value inside here, and I didn't have to move these things at all. It's just I had to make the moves that connect them right here with the little pinky finger and stuff. And so it's really pretty cool stuff. You can also make a linked list operate as a queue. We'll talk more about that later. No big deal. But it's really good when you have to manipulate lots of data. And so that's one of the advantages of using a linked list rather than using an array list, because if you're doing a lot of manipulation, because that cost of movement, this stuff right here, those little connectors that are happening, it's a lot cheaper to move those than to resize the arrays over time. And so we'll talk about that as we get more involved with advanced data structures another time. Check a look at some videos on YouTube or look the chapter inside advanced data structure in your textbook, and you too can find some amazing stuff out. Now, the first one we're going to talk about on the other linear structures is the stack. It is a first in and a last out structure. Now, this forms the basis of computer execution. It's also great for driveway car management, and it's also destructive. So the first example I want to give with that is the amazing power of a stack of crackers. I want to eat the cracker at the bottom. Now, because this is in a stack, the only way to get to that stack is to first consume this cracker. Then I have to consume the next cracker. I know, it's insane. I have to consume the data to actually get to it. Now, that's a problem, because if I'm consuming the data to eat it, we're going to have some real issues with what we're doing. And so we have to make sure it's not always the best choice. The next one we have is the idea of the basis of computer instruction. I'm sure many of you have worked with debug at some point. And when you're looking at debug, you can actually see what's happening inside the execution of the computer right here. I'm working with one of our inheritance projects right now, and you can see I have a breakpoint right here at this, and it lines up with right here at this line 53. I have a breakpoint right here, so the program's running, it's waiting for me, which means it was called right here from 53, which is called from this line 193 right here in this one in Update Pokemon, which is called from PokePanel, which is called from the action performed, which is called from that JButton's fire action, which is called from this, which was called from this, which was called from this, which was called from this. And the only way to get back down to this is to process those steps and get through it. So I can't simply just go backwards through it. I have to consume the information and go step through it so I can actually go through and actually handle the execution steps we're working with to process those instructions. And so the stack, which is this pile right here over here on the left, that's the current stack of instructions that's going with this version of the program. There's an entire other stack of just all the regular operating system stuff happening at the same time as well. And you can see this is happening all the way down from making the actual Poke frame, the event queue itself, calling the run from all the way down here. Earlier, starting off all the way at the very beginning, from when I started the actual running of the program itself. And so all that happens, it's this big, huge stack of events, and it consumes the top one each time until I get back down to the very bottom in order to get to this very first one. The first one was put in at the bottom of the stack. And so that's a quick little example for that as well. One of the other stacks we have to talk about is the idea of driveway car management. Now, yes, I know they're ducks. I don't have any toy cars, though, so I have to use this. Now, we have our ducks right here in a row. And I need to get the car that's in the front of the driveway out. So in order to do that, the first thing I have to do is I have to drive this car out, back it out, put it on the street. Have to take this car out, back it up, pick it out, put it on the street behind the other duck right here. Then I can back out Mr. Purple Duck. Okay, put it on the street. Now I can pull the yellow duck in, put it at the front of the driveway. Then take the red duck, put it into the second spot of the driveway, and the other red duck, and put it in the driveway. And now Mr. Purple Duck can fly away. And so driveway car management is working with the stack as well. And so you want to make sure you have the basic structure of that. Now again, like I said, when we're talking about a stack, it is a destructive structure. And in order to get to that bottom thing in the stack, you have to consume or destroy everything on top of it. So you don't always want to use a stack, but sometimes it's the best option for the structure. The next destructive linear data structure is the queue. Now you've actually been working with queues since you've been a small child. You should know they're called queues. Well, unless you're outside the United States, then you're used to the word queue. It's just like a line. It's a first in, first out system. You've been in lunch lines before. Oh, I'm going to go get my food. Next person, go get my food. Or you line up for elementary school and keeping track of that. You also, say for example right now, you're trying to handle your reservation for your spring break and you're trying to figure out whether or not you're going to be able to get a refund for your wait. Thank you for calling, insert company name here. You are number 5,443 in line. The approximate wait time is 4,442 seconds. Please remember that we appreciate your business and are anxiously waiting to help you. Please hold for the next available agent. Your call will be answered in the order it was received. Yeah, I know. So if you're calling to cancel your reservations, you're already in a queue right now. The most common use on this is also a subclass of a queue called a priority queue. Now, if you've ever gone to any of the major amusement parks, you have the really cool thing like a fast pass at Disney. So you've got your line of people. Again, ducks, they're amazing. Okay, you've got your line of people, and they're in line to go on the ride. But then you've got your fast pass person. Mr. Purple Duck has the fast pass, and Mr. Purple Duck, hey, look, I'm in my fast pass line, and I get to go on before Mr. Person and the yellow duck, and I get to go on the ride. Yeah, I know, it's amazing. Unfortunately, the same structure with a priority queue has been happening right now with the COVID-19, where a lot of famous people or famous people's friends and spouses are able to get access to testing for the COVID-19 virus and are getting treatment at a rate where people who don't have that ability are not getting that treatment even though they're exhibiting symptoms. And so a priority queue has some negative implications as well. So we want to make sure that when we're working with this, we do some good approach. We design structures that are going to help everybody. Again, remember, CS is for all. We want to do cool things and help cool, amazing people. Now, nonlinear data is another thing we have to worry about. Now, I know I said that the two-dimensional array is, we've done it and it's cool. You've got your cute little lovely egg grid if you've worked with these before. It's really just a two-dimensional array. We have rows and we have columns inside them. And remember, inside Java land, a 2D array is just really an array of each row as an array. Great stuff. Now, the 2D array is amazing if you're working with Barb Erickson's project and doing Photo Lab. Really cool stuff. You get to learn some amazing things and do that. We also have, there's a great nifty exercise of making a sand lab with that, where you can practice using a two-dimensional array of ints and use it to predict the sand game. Great way to practice using that nonlinear data. But you can do even more than 2 dimensions. You can have 3, 4, 5, 18,042 dimensions. And, well, yeah. Basically, 3 dimensions is the only time I've ever actually done anything really cool with that, and you're modeling 3D space, figuring out how things are reacting with that. But you can do, sometimes you actually do need more dimensions to solve and reflect other examples of things outside of just the regular physical realm. Talk with your science teachers, see when you're using a multidimensional vector to handle that information. Really cool stuff. The next one we have is the mapper dictionary. This is a one-to-one structure. We'll talk about that. We have a graph or network, and then we have the tree, which is a hierarchical system. And so let's go ahead and take a look at the mapper dictionary structure. With a mapper dictionary, what we're talking about really is a key-value pair. This is implemented in a lot of different styles about this, but we have the idea that we have a key, which is a member of a set, which are discrete and unordered. They don't have to have an order, although when we're talking about a dictionary, for some reason, the dictionary orders all of the keys, aka the words we're looking with, by order, but they don't have to be because it's really easy to find and handle that. Then we have values attached to that, and values can be as complex as needed, and they can even be repeated because you can have the same key, but with different different key can have a different value on it. So if the key of A can have the answer of this, and a key of 4042 can have the same answer, and so that's A-okay, but the keys themselves have to be discrete. One of the main ways we see that implemented is the idea of a hash table or a hash map, and that uses a hash function to have that happen. Look about how we can do some cool stuff with that, with the idea of using passwords and storing information like that. That's one of the main ways we're going to see a map or dictionary in use, but it's really good when you're having a specific, a one-to-one relationship. You can do some cool things with that, okay? When we're talking about a graph, we talk about the need to know the connections between things. So in the case of this Lego creation right here, we have connections between the different black components via the gray things, and of course also these little cables right here, because I'd have something that was a little bit different. And so this black piece is connected to this black piece, it's connected to this black piece, it's connected right here to this one. And this black piece is connected to this black piece is connected as well to this black piece is connected to this piece and to this piece is connected to this piece, and this piece all the way connects back down over to this one over here. And so the connections between things really matter. And one of the things you have to do is these things themselves are great and they're wonderful, you want to store them somehow. But what really matters is the connections between things, because this one right here is even connected to itself, and that connection to itself even matters. There's some real world implications on this as well. COVID again, when we're talking about how are we spreading or watching how the connections matter, when this person talks to this person or sneezes on this person or goes over and visits this person, that path of connections is really important when we're talking about working with a database and the connections between primary and talking about a database and the connections between primary and foreign keys, or working with a network and seeing how you're going to actually hook different systems together, computers or otherwise, and how that's going to happen. And the traversal, how am I going to traverse this implications key? I'm going to go as deep as I can first and then go out, or I'm going to go out as far as I can and then try and go deep. And so that's the basic thing you want to take a look at with that. I've got a couple other videos on graph, and you can take a look at those and do some really cool stuff with that as well. The final nonlinear structure we're talking about is the idea of a tree. Now, a tree is really, really fun. The connections matter and the level of things matter. That one, the level of things doesn't really be important when we're talking about the graph, but in a tree, the levels really matter. The root is at the top of the tree, and it has n children. When we're talking a binary tree, it has at most 2. Each level is also a tree, so every child of that tree is, guess what? You've got it, it's a tree. One of the main ways that we see this is the file system on a computer. So if you're either working with OS X, with Windows, or even with Unix, all those systems use a root-based system to handle that, or a tree-based system, where you have folders, then folders, then folders within folders, and those structures go down, and each structure within it is also another structure. That's a really cool recursive structure. We'll talk about that some more as we go looking at trees later on, but it's the basic introduction we have that. Now, if you take a look outside, those actual trees you see as you're walking out doing your social distancing, those actual trees are upside down because the roots are on the bottom and everything else goes up. I know, it's weird. We'll talk about that some more. But again, a tree is a one where the idea that the structure matters, both the connections and the level. And so it's a nonlinear data structure that has that happen. Just to do a quick review, we have some linear structures beyond Array and ArrayList. We have the vector, which is ArrayList but thread safe. The linked list, which is ArrayList with an enhanced backend for moving data around a little bit better. The stacking queue, the destructive data structures where order matters, and we have some special rules to handle that. On the nonlinear data, we have our n-dimensional arrays when we're talking about having, say, for example, a 2D array, a 3D array, or more. We have our map or dictionary data structure, a graph, which is a network-based data structure, and a tree where we see that hierarchy of information. And remember, trees outside our lives because the root's on the bottom when it should be at the top and have the children going down. Thanks again. Have a great day, and we'll talk to you later. Bye.